Okay, so up to this point, here's kind of the key things that we've learned up to this point. First of all, the definition of sine and cosine, which comes from a right triangle with some reference angle in mind. So let's say this is angle A, and the hypotenuse is 1. So if we have that scenario, we define the sine of A as the length of the opposite side, and the cosine would be the length of the adjacent side. Okay, so that's where our definition of sine and cosine came from. Then we said that the tangent of A is the ratio of sine to cosine. And when we get to finding those things, we find triangles that are right, that are proportional to this triangle, and work that way, right? Then we learn that, hey, there's 3 other trig functions out there, right? So the sine of A is the reciprocal of what? The cosecant of A. The cosine of A is the reciprocal of the secant of A. And the tangent of A is the reciprocal of the cotangent of A. Okay? And so we got our 6 trig functions. And what's important to see here is everything comes from the sine and cosine. So if you can find the sine and cosine, you can get all the other pieces, right? So sine and cosine are the building blocks of the 6 trig functions. We are working with the unit circle. We learned that the unit circle is a circle with a center at 0, 0, and the radius is what? Radius is 1. And so this would be, what would the coordinate at 0 degrees be? 1, 0, because you go right 1, up or down 0. At 90 degrees, you're at 1. At 180, you're at, and 0, negative 1. And knowing coordinates on the unit circle, we found were pretty important, because we found that on the unit circle, those points, the x value represents what? The cosine of theta, and the y value represents the sine of theta. And so if we know, okay, this is 90 degrees here, and I know that coordinate, and I say, hey, what's the cosine of 90 degrees? You say, what's the cosine of 90? 0, because that's the x value at that place. Or if I say, what's the sine of 270 degrees? And negative 1. Okay. What if I said, what is the secant of 270 degrees? Well, the secant is the reciprocal of the cosine. What's the cosine? What's the cosine of 270? 0. What's 1 divided by 0? Undefined. So the secant is undefined. And remember that the reciprocal of 0 is undefined. So what's the reciprocal of undefined? 0. Right? The reciprocals of each other. Okay. And so that was important. And now we're kind of at the point where we're throwing degrees out, and we're replacing them with radians. And in our way we work with that is that 180 degrees is pi radians. But as we're seeing from the homework, that sometimes we make pi look different, right? Depending on what we're working with. So we may make that 2 pi over 2, or 3 pi over 3. or 50 pi over 50, depending on what we want our denominator to be. All those are equal to pi, and we want to make, work with our denominator that the problem that we're using has. Okay, so we're going to put all this together today. Okay, you ready? All right. So let's look at some examples. Example 1. Let's find the cosecant of negative 3 pi over 2. Okay. Cosecant of negative 3 pi over 2. When we do this, the first thing we need to do is locate, okay, where's negative 3 pi over 2? We're working in radians here, and we need to find that position, right? So I start with my coordinates here. Give me a unit circle. And I'm working in radians. I know this is 0 radians. I'm working over 2 though, so I'm thinking fractions. So this is 0 over 2 radians. I'm going in the negative direction, which is clockwise. And at pi, I'm going to put negative 2 pi over 2. So I haven't quite gone far enough. If I go another 180 degrees around the circle at 2 pi, that would be negative 4 pi over 2. And I need to know where negative 3 pi over 2 is. So that's exactly between negative 2 pi over 2 and negative 4 pi over 2. So we're looking at 90 degrees here, right? All right. So when we get something on the x or y axis, the way we handle that is through coordinates. So what's the coordinate of that point? 0, 1. Okay. So I find the coordinate. And then the cosecant, what I'm thinking is a cosecant is the reciprocal of what? The sine. And the sine is the y value. So the y value here is 1. And so I know the sine of negative 3 pi over 2 is the y value, which is 1. And so I need the reciprocal of that. What's the reciprocal of 1? 1. And so finally get to what I'm after, that the cosecant of negative 3 pi over 2 is the reciprocal of 1, which is still going to be 1. Got my answer. Okay, so that's kind of the process. You find the location and you handle it appropriately, okay? Let me give you another example like this one. So example 2, find the cotangent of negative 3 pi. Go ahead and try that one. What are we getting? Okay, I don't know, and I hear undefined. I hear both those, okay? Were you able to locate negative 3 pi? That's the first step, right? Locating negative 3 pi. You can't locate that, then you're going to be in the I don't know category, right? So 0 radians is at our starting point. It's negative, so I'm going in the clockwise direction. So this would be negative pi. Keep going. We're just counting by pi here. This would be negative 2 pi. And I need to find negative 3 pi, so I keep going. And this is also negative 3 pi. So negative pi and negative 3 pi, we say they're coterminal because they're in the same location, right? And think about it. If you have negative pi and subtract 2 pi, you end up with negative 3 pi, right? So because we're on the x-axis, we handle this one without a triangle. We just find the coordinate of that point, which is Negative 1, 0. Okay, your x value or your cosine is negative 1, and your y value or your sine is 0. And so if we think about the tangent of negative 3 pi, that's the sine of 3 pi over the cosine of 3 pi, right? Sorry, negative. So if I want, but I don't want the tangent, I want the cotangent. So the cotangent is the reciprocal, so what I do is I flip that over, and that's cosine over sine. And cosine is our x value, and sine is our y value. And our x value is negative 1, and our y value is 0. And whenever you have a 0 in the denominator of a fraction, you can't have that. We say that's undefined. Can't divide by 0. Okay? And so we say the cotangent of negative 3 pi is undefined. Okay? All right. Try another one. Example 3. Find or evaluate the secant of, let's go with 5 pi over 6. All right, so locate 5 pi over 6. If it's in a quadrant, then you're going to have to find the reference angle and work with a triangle, okay? And in this case, you will have to do that. Give it a try, though. All right, so first of all, what quadrant is 5 pi over 6 in? You're getting 2, you're in the right place, okay? Here's why. So, unit circle, here's 0. Now, it's over 6, so this is 0 over 6, same thing, right? And I'm going, it's positive, so I'm going in the positive direction. Half a circle will be pi, but it's over 6, so I'm going to write 6 pi over 6 here. And now I've gone too far, so I know it's in quadrant 1 or quadrant 2. And 5 pi over 6 is closer to 6 pi over 6 than it is 0, so somewhere right here. So what we need now is our reference angle. The reference angle is the difference between 5 pi over 6 and 6 pi over 6. It's the positive difference, which is pi over 6. Now here's where I always convert these to degrees. And we know that pi is 180, so this is 180 degrees over 6, which is 30 degrees. Okay? So you're either going to get, when you're working with the unit circle, you're going to get over 6, over 4, or over 3 when it's in a quadrant. Those are the only ones. And so pi over 6 is 30. Pi over 4 is what? 45. And pi over 3 is 60. Those are the three reference angles that those are the only three reference angles that we know how to work with, because we have the 45, 45, 90 or the 30, 60, 90. That's all we have, right? And so that's what we're looking for. So we know this is 30 degrees. Hypotenuse is 1, and we need to remember the side lengths, don't we? So across from 30 is what length? 1/2. And the base is negative root 3 over 2. Okay. So then secant is the reciprocal of cosine. And so we could say the cosine of 5 pi over 6 is our x-coordinate. What's our x-coordinate here? Negative root 3 over 2. And so the secant will be the reciprocal of that. which when you flip that over, it looks like this. And then we rationalize our denominator by multiplying top and bottom by root 3. And we get negative 2 root 3 over 3. That's what we're after. Okay? Question on this? Okay. This is putting it all together though, right? Question, yeah. So you converted the radians to degrees earlier than I did? You found out what 5 pi over 6 was? And that's fine, you can do that. But you could do it this way too. You know, the less converting you have to do, especially if you don't have a calculator, a little less, a little easier it is for you. Before we leave this one, let me ask you, what is the coordinate, like the actual point on the circle right there? That's the angle. What's the coordinate? Like from 0, 0, how far left do I have to go and how far up do I have to go? Negative root 3 over 2 is my x value, and my y value is 1/2. That's the actual point on the circle. Right? You see that? I mean, it's written here, right? That's what we're writing here. But that's the point on the circle. And I want you to make that connection. Because the x value represents cosine, y value represents sine. Okay, all the way around that circle. Another example. Example 4. Evaluate, which is what we're doing, find, okay? Evaluate the tangent of negative 15 pi over 6. Well, actually, let's do negative 15 pi over 3. Over 4. Over 4. The reason I didn't say 3 is because you can reduce that, right? I didn't want to be able to reduce. Okay, what quadrant are we in? We're in quadrant 1. You sure? Okay, let's check. So 0 degrees, or 0 over, not degrees, radians. 0 over 4 radians. Going this way. Half circle, we're at where? Negative 4 pi over 4 radians. Go another half. Gotta go around a lot, huh? Negative 8 pi over 4. Oh my. Negative 12 pi over 4. Negative 16 pi over 4. Okay? So 0 over 4, negative 8 pi over 4, and negative 16 pi over 4 are all coterminal at the same location. And so we see that, okay, negative 15 pi over 4 is going to be pretty close to the negative 16 pi over 4 in quadrant 1. And so we're really after, okay, what quadrant are we in? We know we're in 1. And what's our reference angle? Our reference angle is the difference between, the positive difference between 15 pi over 4 and negative 16 pi over 4, which is pi over 4. And as we said, we're either going to have one of 3 reference angles, pi over 3, pi over 4, or pi over 6. And so because pi is 180, what's 180 degrees over 4? All right, so 45 degrees. So this is a 45, 45, 90 right triangle. Hypotenuse is 1. What's the side lengths? It's isosceles, remember. Root 2 over 2 and root 2 over 2. And tangent is the sine over the cosine, but sine is y, cosine is x on the unit circle. And so root 2 over 2 divided by root 2 over 2, which is 1. All right?